In triangle ABC, the altitudes from B and A intersect at H and have feet B prime and A prime respectively. B prime A prime intersects BA at P, and M is the midpoint of BA. Prove that the perpendicular from P to AC always passes through one of the intersection points of MH with the circumcircle of triangle BA prime P. We have Michel's theorem, which I pulled up from USAMO, and it's used on a complete quadrilateral ABCD with P equals AD intersect BC and Q equals AB intersect CD. And Michel's theorem is relevant here because we have a complete quadrilateral AB, A prime, B prime, where C equals BA prime intersect AB prime, and P equals AB intersect A prime, B prime. And Michel's theorem states that the four circles PAB, PDC, QAD, and QBC concur at the Michel point M. In the case of quadrilateral AB, A prime, B prime, we have that the circumcircles of triangles A prime, B prime, C, ABC, and BA prime P. There's also B prime AP, but that's too big, so I decided not to include it here. They all concur at a single point, Q. Using our improved diagram with Q as the Michel point of quadrilateral AB, A prime, B prime, it looks like MH and Q are collinear. So we conjecture that they are collinear, and we have to prove that they are. And we can use properties of Michel points to do so. So recall that the Michel point of any cyclic quadrilateral, in this case AB, A prime, B prime, is cyclic because both this angle AB prime B and A prime B are right angles. So that makes the quadrilateral cyclic. The Michel point of any such cyclic quadrilateral is simply the point where its diagonals intersect, projected onto the line formed by the points where opposite sides meet. So in this case, the diagonals intersect at H, and the points where opposite sides of the quadrilateral meet are C and P. So Q is the orthogonal projection of point H onto line CP. So we can write angle CQH equals pi over 2. But Q also lies on the circumcircle of triangle ABC. So we can extend that line to hit the circumcircle at point C prime, which is opposite C. And so now we know that both H and C prime lie on the line, and M is the midpoint of HC prime. C prime is just the reflection of H over M by the very famous reflecting the orthocenter. So now we know that since C prime, M, and H are collinear, line MH is just line C prime H, which since both of these angles are equal to pi over 2, it passes through Q. So we now know that line MH passes through Q. That's one of the intersection points, and not necessarily the point that the problem is talking about, where the perpendicular from P to AC intersects. That's going to be the other point, which we denote by X. And now we want to prove that line PX is perpendicular to line AC. So if line PX intersects AC at P prime, then this angle here is a right angle. I just won't mark the right angle yet because we haven't proved yet that PP prime is perpendicular to AC. Now we established earlier that angle XQC is a right angle. So proving that angle PP prime C is also a right angle, or angle XP prime C, which is opposite Q, is also a right angle, is simply the same thing as proving that quadrilateral P prime CQX is cyclic. So we want to prove that quadrilateral P prime CQX is cyclic. And the best way to do that, believe it or not, is to start up here at angles at A prime, B prime, and B. So earlier, we established also that quadrilateral AB, A prime, B prime was cyclic because of the two right angles. So angle A prime, which is this angle over here, is pi minus A. And this angle here is pi minus B. So these angles outside the quadrilateral, they need to be equal to A and B. And now we can do some angle chasing. Since this is just angle B, we have this is equal to pi minus B. And using cyclic quadrilateral PX A prime B, we have that angle PX A prime here that's just equal to pi minus angle PBA prime, which is pi minus B, which is just B. And on the other side from this angle B lies pi minus B. And that's equal to angle A prime x P prime, which is opposite from B in quadrilateral B prime A prime x P prime. So that quadrilateral is cyclic. And the reason it's cyclic is because opposing angles add up to pi. So now we can do power of a point at P. We know that PA prime times PB prime equals PX times PP prime. But what else is PA prime times PB prime equal to? Well, those points also lie on the circumcircle of triangle A prime B prime C. So we can use the power of point P with respect to that circle. And we get that PA prime times PB prime is equal to PQ times PC. Now, the right sides are equal, obviously, since the left sides are equal. And so we have that quadrilateral XP prime CQ is cyclic, which is exactly what we wanted to prove. So if angle XQC is equal to pi over 2, so is angle XP prime C. And now we have proved that PP prime or PX is perpendicular to AC. So there we have it. The perpendicular from P to AC always passes through X, which is one of the intersection points of MH other than Q with the circumcircle of triangle BA prime P. Thank you for watching my YouTube video, and please follow my channel if you would like to see more videos.